We've introduced the concept of integrating with respect to a single variable, even in a multivariable function. So let's take a look at a specific example. Let's say that I have this multivariable function, 2xy plus 3y squared. I'm integrating from 1 to x, and I'm integrating with respect to y. Well, I can integrate each piece individually. Integrating with respect to y, I add 1 to the power of y, and I divide by this power. So the 2 gets absorbed here. And then I add 1 to the power of y to get 3, and I divide by 3, so that gets absorbed as well. So now I have something with x's and y's, and for each of the y's, I sub in the upper limit, x, and I subtract, subbing in the lower limit, y, just like we've done in introductory calculus, and end up with 2x cubed minus x minus 1. So the big thing to take away from this is that for this whole function, at the end of the day, what I have is something in terms of just an x. All of the y's get absorbed because we're doing a definite integral. So your answer should have no y's in it. So if you think about that, at the end of the day, the output of that integral is some function of x. So the output of the integral is actually a function. So I'm going to define that function as the integral, because whatever I plug in for x, if that was a number, it would change the output there. But what if I wanted to integrate that function? So now I'm taking an integral of an integral, okay? So if I did this without pre-computing, right, because this integral, I could just slap that right in there and I wouldn't have to worry about it. But if I did it before pre-computing, I would have an integral of this sub-integral, where this is what's called the integrand, and then that's the variable we're integrating with respect to. This term is called an iterated integral. So it's an integral of an integral. And in general, you won't see these brackets written. So when you see an iterated integral, you'll just see integral symbol, this inner function dy dx. And we could go ahead and solve it. You could run it all the way through. What you're going to get in this particular case is 5. Feel free to work that out as you need to. That's just a standard introductory calculus integral. But the key to watch out for here is there was something that might be missing. You could write iterated integrals in 2 different fashions. You could write them as dy dx, or you could write them as dx dy. Whichever differential term comes first is the one that you integrate with respect to first. So notice in this case, dy was inside, or was first here, so we integrated with respect to y, then with respect to x. So notice that our limits here are with respect to x, because we're going to integrate this, or we're going to antiderive it, sub in the limits for x, and then you have just a function in x, and you integrate with respect to x. Whereas down here, I have some functions with respect to y, so I integrate in x, sub in values in y, then integrate in y. But ultimately, you get something like this. The idea is you're iterating. They call it an iterated integral because you might have 3 of these with a dz. So you integrate with respect to one variable, then a second variable, then a third variable, and so on and so forth. You can integrate with any number of variables for an iterated integral. But just remember that the order here affects things. You have to integrate with respect to the order. So these go together, these go together.